Let your mind settle. As the day ends, we turn our attention outward to the deep and quiet dark. The space between the stars is not empty. It is an ocean, vast and ancient, and through it, things are moving. For millions of years, an object has been on a journey, a visitor cast away from its own star system, drifting through the interstellar void in absolute cold and silence. It is a piece of another world, and now its long silent pilgrimage has brought it to us. We found it not as a spectacle, but as a whisper. Automated telescopes, patiently scanning the sky, flagged a new faint speck of light. As they tracked it, night after night, they saw it was not one of ours. Its path was wrong. It was moving too fast, on an orbit called a hyperbolic trajectory. This is the mathematical signature of an object that is not bound by our sun. It is a traveler just passing through. We call it Three-Eyed Atlas, the third interstellar object ever confirmed. This visitor is a time capsule. As it falls inward toward the distant, warming light of our sun, its ancient surface begins to stir. This far out, it is not water that wakes. It is more volatile, something like frozen carbon dioxide, CO2, which we call dry ice. This CO2 turns directly from a solid into a gas, a process called sublimation. This gas builds a faint, shimmering cloud around the dark nucleus. This cloud is the coma. As the sun's light passes through this thin, alien atmosphere, it causes the gases within to glow. We see the soft, spectral green of dicarbon, the swan bands, a gentle, ethereal light that tells us its journey is no longer a silent one. We are watching it calmly with our best instruments. We know its schedule. It is a quiet encounter. It will make a close pass of the planet Mars on October 3rd, 2025. It will then face its greatest trial, a close pass of our sun, its perihelion, in late October. Our eyes in orbit, Hubble and JWST, are turning to stare, not in alarm, but with a deep, quiet curiosity. They are waiting to read the light from this visitor, because in that faint green glow are the chemical secrets of a star system we will never see. This faint, ancient light, having traveled for millions of years, finally arrives at our telescopes. And in its last moment, we catch it. We do not just take a picture, we read its message. We use a method called spectroscopy. It is a gentle, passive act of listening. Think of the comet's light as a single, combined chord, played on a distant piano. A spectrometer is the prism, the translator, that carefully separates this chord back into its individual notes. It takes the pale white-green glow and stretches it out into a long, thin line of colors, a spectrum. But this spectrum is not a perfect, smooth rainbow. It is a barcode. It is filled with tiny, sharp, bright lines. Each line is the unique, unmistakable fingerprint of a single element, a single molecule, glowing in the sun's warmth. As we calmly examine this barcode, the comet's story begins to emerge. The first and boldest line we see is the signature of carbon dioxide, CO2. This confirms our suspicion. This is a deep freeze object, an object whose engine is not water, but the dry ice that sublimates in the deep cold. We also find the fainter signature of OH, or hydroxyl, a fragment of water. This tells us H2 is there, locked in the ice, but the CO and $2 is in command. And of course, we see the beautiful, distinct cluster of lines that we call the swan bands. This is C2 dicarbon, the true source of the comet's soft green halo. Then, in this quiet data, we find a puzzle, a delicate, unexpected line. The barcode signature for the metal nickel, not Kieran. This is not impossible, but it is unusual so far from the sun. But the real curiosity is what is not there. In our solar system, where we find nickel, we almost always find its companion, iron, Fe. Their chemical fingerprints are usually found together. But here, in this alien's light, the space where iron's barcode should be is empty. There is no fear in this observation, no alarm, just a quiet, unfolding wonder. We are reading the chemistry of a rock from another star, and it is telling us that its home is different from ours. We have read the comet's light. Now we feel its motion. This object is more than just a passive rock falling toward the sun. It has its own engine. It is a quiet one, almost silent, but it is persistent. Engine is the same one that creates the coma, the gentle sublimation of solar ice. As sunlight warms the day side of the comet's nucleus, the ice turns to gas, and these gas molecules stream away. This stream, this faint, invisible breath, acts like a tiny thruster. A single molecule has no force, but trillions of them, all leaving in the same direction, create a persistent, gentle push. It is a whisper of a force, but in the frictionless void of space, a whisper is all you need. This gives us a beautiful, calm way to measure the comet's power. We can calculate with perfect precision the path 3I Atlas should take if it were just a dead rock, pulled only by the sun's gravity. We can call this the predicted path, but we can also observe its actual path, night after night, and we find they do not match. The comet is drifting, slowly but measurably, off its gravitational course. This tiny deviation, this non-gravitational acceleration, is the direct physical proof of the comet's engine in action. We can measure the gap between the two paths and calculate the exact tiny force its CO2 engine is producing. This is different from another gentle force acting on the comet. Sunlight itself, the photons, also exerts a pressure. This radiation pressure is too weak to move the heavy nucleus, but it is strong enough to push the tiniest, lightest particles of dust that have been freed by the gas. This is what separates the gas from the dust, pushing the dust into its own broad, curved tail. So we have two gentle engines, sublimation, pushing the nucleus, and sunlight pushing the dust. There is no violence here, just the calm, steady, predictable laws of physics, shaping the path of this interstellar traveler as it glides through our solar system. We have learned that this traveler's light tells us what it is made of, and its motion tells us how it is powered. But what we see is not always the truth. It is often a question of where we are standing. As observers, we have seen a quiet puzzle in the sky. We know that a comet's tail, pushed by the sun's own light, must always point away from the sun. And yet, in many photographs of 3I Atlas, we see a second, fainter tail, a sharp, narrow spike that appears to point toward the sun. This is the anti-tail. It seems to defy physics, but the answer is not in new physics. It is in perspective. This is a simple, elegant trick of geometry. The comet's engine, the sublimating CO2, releases gas, but it also releases fine dust. Sunlight gently pushes this fine dust away to create the main tail. But the comet also releases heavier particles, grains of sand and small pebbles, left over from its creation. These grains are too heavy for sunlight to push easily. They are simply left behind, like a trail of breadcrumbs, drifting in the same exact orbital path as the comet itself. Over thousands of years, this trail of heavy dust spreads out, forming a vast, flat, thin sheet, like a ring of dust, perfectly aligned with the comet's orbit. We only see the anti-tail at a special moment. It happens when our own planet, Earth, in its orbit, passes through that thin sheet of dust. At that moment, our viewing angle changes. We are no longer looking at the sheet. We are looking along its edge, just as a piece of paper, seen edge on, looks like a single thin line. This vast, diffuse sheet of dust, when seen edge on, concentrates all its reflected sunlight into one sharp, bright spike. It is an illusion, a beautiful, peaceful illusion of perspective. This gives us a simple, calm way to check our understanding. If the anti-tail is just our point of view, it should vanish if we look from somewhere else. This is a prediction, and in October of 2025, we will have that chance. As 3I Atlas passes Mars, our orbiters there will have a different view. From their perspective, they will not be edge-on, and from there, the illusion should dissolve, revealing the true, broad fan of dust, just as we expected. We are not bound to a single point of view. The solar system is large, and we have quiet sentinels in orbit around other worlds. Our test, our gentle prediction about the anti-tail, required a second vantage point. It required a new perspective. It required Mars. On October 3, 2025, the Comet 3I Atlas glided peacefully past the red planet, and our fleet of orbiters, normally tasked with studying Mars, paused their work. They turned and looked up. The ExoMars Trace Gas Orbiter, or TGO, the Mars Reconnaissance Orbiter, MRO, with its powerful high-rise telescope, and MAVEN, our space weather station. This was not a mission of urgency, but of quiet confirmation. The prediction was simple. If the sunward spike, the anti-tail, was truly an illusion of Earth's perspective, it must vanish when seen from Mars. The data from that flyby has now arrived. The images, taken by HiRISE, are definitive. The spike is gone. From the Martian point of view, 3I Atlas shows its true form, a broad, gentle fan of dust, spreading gracefully along its orbital plane. The illusion dissolved, just as the laws of geometry said it would. The universe is orderly. What we mistook for a paradox was simply a matter of where we stood. Our other instruments added to this quiet picture. TGO's spectrometer confirmed the strong CO2 and C2 signatures, a clear reading without Earth's atmosphere to blur the light. MAVEN tasted the solar wind, confirming the space weather was calm, allowing us to see the comet's own intrinsic light. We have used a second planet to solve a riddle of light, and now, in late October 2025, the comet has reached perihelion, its closest approach to the Sun. It is now gliding into solar superior conjunction, a period where it is perfectly aligned behind the Sun from our point of view. The Sun's brilliant light, which gave the comet its glow, now hides it from our view. The data from Mars is safely archived, and so we wait. We wait for the comet to complete its turn and to reappear calmer and dimmer in the quiet of December. The Sun's light, which brought the comet to life, now hides it. It is currently in solar superior conjunction, lost in the bright glare of its late October perihelion. But the orbits are precise. The dance is predictable. In December 2025, the comet will swim back into our view. It will be changed. It will be dimmer. Its journey past the Sun will have cost it, and its CO2 engine will be throttling down as it recedes once more into the cold. The data from the Mars flyby is waiting. When it is all downloaded, the full story will be clear. The green glow is the C2 swan bands. The strange sunward spike we now confidently predict will be absent in the Mars images, confirming it as a beautiful, peaceful illusion of geometry. We have already measured its non-gravitational push, the gentle, steady thrust of its alien engine, and we have its chemical barcode, a fingerprint that reads carbon dioxide, with that quiet, lingering question mark, the signature of nickel, without its partner, iron. The comet's time in our system will then be ending. It will be on its long, outbound arc, it has one final scheduled encounter. On March 16, 2026, its path will cross the orbit of Jupiter. It will not pass close, but Jupiter is so vast that its gravity will reach out, a final, gentle hand. That gravity will give 3i Atlas one last tiny nudge, slightly altering its path. This is the solar system's farewell. That nudge will seal its trajectory, its final hyperbolic exit path. Our telescopes will take one last long look, capturing the last of its fading light. The data will be archived, the visitor's message received. Our Atlas, a traveler from an unknown star, will return to the quiet, interstellar dark from which it came. And our solar system, and all of us on this world, continue our own steady, silent orbit.